First questions first. Why would anyone want to live on the sun? The first and best answer is energy. Indeed, the need for energy has become one of our greatest drives. In general, as a civilization grows more technologically adept, it requires more energy to sustain its growing population and cutting-edge science. Space shuttle launches, for example, require as much energy as 400,000 cars do, with each launch generating 44 million horsepower and burning 11,000 pounds of fuel a second, according to NASA figures. So how do we possibly sustain that? Fossil fuels are limited and will eventually run out, not to mention the long-term problems we now know they cause. So the race is on to find and harness alternative fuel sources that will provide enough energy for our increasing needs. Space travel being just one of those needs. The strongest potential source is undoubtedly the sun. It creates a truly mind-boggling amount of energy, but the problem is that only a minuscule fraction of it ever reaches Earth's surface at the moment, for a variety of reasons. The best chance we have of capturing more of that energy, then, is to move closer to that source. The sun doesn't have a physical surface, so we would need to build something around it, like a gigantic space station, but one that could also withstand truly extreme temperatures. The first major stumbling block is that we would require an enormous amount of material, an amount that we currently don't have. Freeman Dyson, the scientist who famously envisioned the Dyson sphere, has before highlighted the same issue. But say we were able to somehow locate an endless supply of sustainable material. What about the design? To successfully float above and close to the sun, there are two main options. Our station would either need to be going at an extreme speed around the star, which means continuously firing fuel to counteract the gravitational pull, or it would need to be a connected structure around the star, and immeasurably robust to be strong enough to hold. Most likely, we'd need a combination of the two. A sturdy frame supported by always-on thrusters to correct drift. But say after years, probably centuries of planning, we have somehow managed to build a sun station that doesn't break and doesn't instantly kill anyone or anything that arrives there. Next question, how would it operate? With advanced solar panel tech, it would have effectively endless power, although so much of that power would be needed first and foremost to keep the station running. The temperature of the sun ranges depending on how close to or deep into you travel, but it soars past 10,000 degrees Fahrenheit even on the outer layer photosphere. That's a lot of energy to convert, but also a lot of air conditioning to run, amongst other temperature-regulating technologies. One possibility to offset some of the heat could be to chase sunspots around the sun and position the station over them. These darker, cooler locations can be up to 30,000 miles across, and when they pop up on the solar surface, the temperatures within them drop down to around 6,000 degrees Fahrenheit only, which is still incredible, but just slightly more manageable. Elsewhere, we'd need the harvested energy to maintain how our station moves, to ensure that it always stays in the optimum position, in a similar way to how the International Space Station operates high above Earth. We'd also need a system for negotiating and avoiding all the rocks, dust, and debris that surround the sun, to ensure that our solar home doesn't get shattered on a daily basis. And we need to keep our eyes on the inside as well, to be constantly aware of solar prominences, which are large bouts of plasma that burst out from the sun like tentacles. Worrying for anyone trying to spend any amount of time near the sun, these can stick around for months. And while they would undoubtedly be spectacular to look at, our station would need to be strong enough to withstand them, because they'd be spectacularly dangerous too. Day-to-day life on a sun station probably wouldn't involve seeing the sun all the time though. Looking directly at it from Earth is dangerous enough, so peering into its bright and fiery depths at such close quarters would probably fry your eyes out in a second. The station could have purpose-built observation rooms, however, with windows featuring ultra-advanced, likely very expensive, tinting technology. From these rooms, if they were possible, the sun would look like an ocean of magma with plumes of plasma erupting from within. It would dominate the sky and the horizon, and from the confines of the station, there truly would be no escaping it. Day and night on a station would have to be artificial periods, of course, since there would be no natural night to enjoy there. On the ISS, astronauts can continue their regular circadian rhythms as best they can by using light bulbs that dim throughout the day. So we definitely need those on the sun station, and some extremely thick blinds and shutters for the windows. We'd also need something to artificially achieve regular human-friendly levels of gravity, which around the sun would be comfortably enough to destroy our bodies otherwise. Food and water would be a real problem too, as all of it would have to be made on the station, or else perilously delivered via resupply ships. At least getting rid of waste would be simple, because we could, with a mostly clean conscience, quite easily dump it into the sun to burn up. But really, it's incredibly difficult for us to imagine such a life, mainly because by the time we become advanced enough to live around the sun, we'll also have changed immeasurably from what we are now. The sheer fact that a sun station exists would mean that humanity had already catapulted itself into an altogether different era of technology. Available energy would be endless, spaceflight would be a common and booming business, and colonizing different planets would be a relatively easy task. From here, we might have our eyes set outwards further still toward interstellar travel and faraway exoplanets. Perhaps one of our greatest problems at this stage would be not where are we going to get the energy from, but how are we going to store the energy that we have? Traditional batteries will have antiquated beyond use by then, while emerging technologies might include the possibility of storing energy in fluids instead, or maybe just in the air, forever accessible all around us. But finally, what of Earth in this hypothetical future world? Most likely, our first flights toward the center of the solar system, during the early stages of building our sun station, will have been made with our home planet in mind. Our endless need for energy on this world will have sent us to the bright and burning edges of another. And so if we were to also develop a means of channeling the sun's energy directly back to Earth, then perhaps our planet would go from strength to strength, even if it will have also undoubtedly changed amidst an unprecedented technological boom. But the immense distances and the incredible challenges involved would still play a part. And maybe when you settle down on the edge of a star that's some 93 million miles away from the planet you used to live on, you never really intend on returning. If it ever becomes possible to live on the sun, and if humans ever choose to do so, then our species and civilization will have taken a huge and unreturnable stride out into the cosmos. In human history, the sun has been variously worshipped as a god. It's seen as the bringer of life and the reason why we've managed to survive until this point. But if the time comes where we can call it home, then our place in the universe will have certainly changed forever. And that's what would happen if it was possible to live on the sun.